Let's consider in case of electrostatic how we can represent work and energy of this electrostatic system. Work, as we know, is defined as W equals integration from point A to point B. If we move something from point A to point B, force times the line element and line integral over this. In the context of electrostatics, if we consider a charge capital Q, move it from point A to point B under the influence of electric field E, then the work done can be written as minus Q E dot dl, which is according to the definition of potential Q times VB minus VA. And clearly this answer is independent of the path that one takes from point A to point B. So, VB minus VA equals work done over the amount of the point charge that has been carried. And if one wants to bring a point charge Q from infinity and bring it to a position with position vector r and stick it there, how much work is done? The amount of work done in this process would be Q times VR minus V infinity, just like what we have seen earlier. And if we set this to 0, we find that the work done is nothing but Q times the potential, the electrostatic potential at the point r. Physically, we can interpret the electrostatic potential as the amount of work done to bring unit charge from infinity to a point r. This is the physical interpretation of electrostatic potential. Now, let us consider the energy of a charge distribution comprising few point charges. So, we have seen that if we bring some energy, some point charge in an electrostatic potential, we have to work. But if initially there is no charge, then if we bring one charge, the first point charge, we do not do any work. Starting from the second charge, we start working. So, in order to bring the charge Q1 from infinity to the position R1, no work is involved. Now, if we bring Q2 from infinity to the point R2, then that involves some work. Let us call that W2, that can be given as Q2 times V1 R2. V1 is the potential due to the first point charge, which is 1 over 4 pi epsilon naught Q2 times Q1 over R12, this much. Similarly, we can write down W3 equals 1 over 4 pi epsilon naught Q3 times Q1 over R13 plus Q2 over R23. W4 equals 1 over 4 pi epsilon naught Q4 times Q1 over R14 plus Q2 over R24 plus Q3 over R34, and so on. And so, with this distribution, what is the total amount of work done? Total work done can be calculated for these 4 charges as 1 over 4 pi epsilon naught Q1 Q2 over R12 plus Q1 Q3 over R13 plus Q1 Q4 over R14 plus Q2 Q3 over R23 plus Q2 Q4 over R24 plus Q3 Q4 over R34. This would be the amount of total work done in order to make this assembly of 4 charges. And if we can now generalize for n point charges the total amount of work done in a summation notation, we can write for n number of point charges, the total work done capital W, that can be written as 1 over 4 pi epsilon naught sum over I equals 1 to n sum over j, which is always greater than I, and that also runs up to n, Qi Qj over Rij. Now, we can remove this constraint, that is j is greater than I, by introducing a factor of half, because if we remove this constraint, we will count each such term twice, and if we count it twice, we can adjust it by introducing a factor of half. But still we will have to consider that j is not equal to I. So, we can write the work done as 1 over 8 pi epsilon naught, including that factor half, I equals 1 to n, j not equals I, that runs up to n. With j equals I, we will have Rij going to 0 and we will run into a problem. So, we avoid that condition, Qi Qj over Rij. This is the energy, and that is nothing but half sum over I equals 1 to n Qi j not equals I up to n 1 over 4 pi epsilon naught Qi over Rij, which suggests that this is equal to half sum over I equals 1 to n Qi times this part, this term in the parenthesis, we recognize that this is the potential at the point Ri due to the other charge distribution. Sorry, here this index must be j. So, this is something we learn from this exercise, that is the work done in a point charge distribution is, if we bring in a charge Qi in the vicinity of an assembly of point charges, the work done is bringing its potential due to the previous charges multiplied with the amount of new charge and sum over all such new charges, and half of that is the work done for bringing all those charges and assembling at one place.